Hello again. We are on lesson 1 for today. We're looking at distance. This starts on page 27. Today's goals. Today we are going to find the length of a number line and then also find the distance between 2 points on a coordinate plane. So first of all, what is distance? It is the amount of length from one point to another. So what we're first going to look at are number lines. Let's look at example 1. So with number lines, you can go about it 2 ways. You can use the equation that they've given you here in the key concept box, or because it is a horizontal line with even units marked, an easier way might be to count. So in example 1, they're asking us to find the distance from C to F. Now the equation tells us if we take 1 unit and subtract it from the other unit and take its absolute value, that will be the distance. So here, x of 2 would be 5, and that is point F, and x of 1 would be -1 because that is point C. When you simplify that further, minus minus turns into plus plus, so 5 plus 1 is 6. And the absolute value of 6 is still a positive 6. Or you could have flipped it, all right? Instead of 5 minus a -1, you could have done -1 minus 5. And if you simplify this further, so -1 take away a positive 5, that's gonna give you a -6. But because that -6 is in an absolute value, it still turns positive. So either way you go about it, it's still gonna give you the same answer. Let's look to the side here. It says, why do you think the distance formula uses absolute value? Well, if we talk about distance, that applies to the real world. It is a length. And again, anytime you talk about length, distance, measurement, all those things can never be negative values. So just ask yourself if it makes sense. Like if I ask you, hey, what's the distance between you and your friend sitting across the room? You're not going to use a negative measurement. All right, so that's the reason there. Now, I mentioned before there's an easier way, right? If I want to know, okay, what's the distance from C to F? Well, on a number line, I have evenly marked units, so you can simply count, right? Start at C and count until you reach the other point. So that would be 1, 2, 3, 4, 5, and 6. Okay, so it's up to you guys how you would like to go about number line problems. Right now, pause the video, go ahead and try the check on your own, and let's see if you get it correct. Find the length of A to E. A is at -5, E is at 7. So you could either do -5 take away 7, or 7 take away a -5. So -5 take away 7 is going to be the absolute value of a -12. 7 take away a -5, that's minus minus, so it turns plus plus. So that's the absolute value of a +12. Well, these are both going to turn positive because of that absolute value. So the distance from A to E is C, 12. All right, on to the next page. So example 2 asks us to determine segment congruence. So you're still using what you did in example 1, right? Figuring out the actual lengths of the segments. But now we're trying to figure out, are 2 segments congruent to each other? So thinking back to our previous lessons, okay? What does the term congruence mean? If we turn to page 22, that was lesson 1.3 where we talked about line segment congruence, right? So congruence means that 2 figures have the exact same shape and size. Here they've laid out what we need to do. We have to figure out, are CB and DF congruent? So from C to B, okay, if you want to use the formula, so B is at -3, C is at -1, which they've already filled in for you. So -3 take away a -1, minus minus turns plus plus. So -3 plus a +1 is going to give me a -2. But that is within an absolute value. So that's going to turn into a +2. Now let's determine the length of DF, because that's the two segments that we're comparing, CB and DF. So F is at a positive 5, which they've already filled in, and we are going to subtract the point that D is at, which is 2. So 5 take away 2 is 3, and that's within an absolute value, so it remains positive. We have one segment that is 2 units, one segment that is 3. So are they congruent? No. All right, go ahead and pause the video, try the check, and we'll see how you do. So for the check, I'm just going to use the counting method. So it's asking determine whether AC and BD are congruent. From A to C is 1, 2, 3, 4, 5, 6 units. B to D is 1, 2, 3, 4, 5 units. So are they congruent? No, the segments are not congruent. All right, now we are looking at the next page. It says learn distance on the coordinate plane. A coordinate plane, that's just a fancy term for a graph. So again, we learned planes are two-dimensional, and because a coordinate plane can contain coordinate points, it's just going to be a graph like this, okay? So when we're trying to figure out distance on that coordinate plane, we have to use a formula unless the line is perfectly drawn within the coordinates. And what I mean by that is, let's say I'm working with this coordinate plane here, and I have a perfectly vertical line, okay? And let's say I want to know the length from point A to point B. Because again, that line is perfectly on those coordinates, I can treat it just like I did here on my number line and count the units, right? Simple as that. So from A to B, that would be 1, 2, 3, 4, 5, 6, 7, 8 units. That is the distance. So if I have a perfectly horizontal line, and I did not draw it perfectly, okay, but if I wanted to know from point D to point C, again, all you would have to do is count 1, 2, 3, 4 units. Sometimes that's not the case. I might have a line like this. So this makes it a little bit tricky to count along the coordinates, just because if you look closely, like right here, okay, that's not even on an exact intersection. And then this point here is halfway between the coordinates. So that's gonna pose a problem whenever we're trying to do the counting method. So that is where the distance formula comes in. Now I've made a note here. It says on TCAP reference sheet. So on EOC, everyone will receive one of these. It is a math reference sheet with all kinds of formulas and conversions that you guys are allowed to use on your end of course test. It's front and back. So we've got this portion here, and we've also got the back. I've actually already highlighted the distance formula. So, you know, in past years, I've had my kids actually remember the distance formula, but you guys don't have to, because it will be here on that TCAP reference sheet. So the formula states x of 2 minus x of 1 squared plus y's of 2 minus y's of 1 squared. If you take the square root of all of that, it's going to give you the distance from one point to another. So let's see how that works here in example 3. It says find the distance between J, which is at 4, 3, and K, which is at -3, -7. And so they've went ahead and identified which one's going to be your x of 1, y's of 1, and which point's going to be your x of 2, y's of 2. So here they said J would be x1, y1, okay? I always like to go ahead and label on top which one's which. And K, they said, would be x2, y2. Now, do you have to always make the first one x1, y1 and the second one x2, y2? No, you don't have to. If you wanted to flip them, so if you had J at 4, 3, if you wanted to make that one x2, y2 and K at -3, -7, If you wanted to make that one x1, y1, that is perfectly fine as long as you put the points in the correct spots of the formula. Just for the sake of this example, let's go ahead and do it the way they did it. We have the original formula. Now let's plug in what we know. X of 2, we said was -3. Y's of 2, we said was -7. Now let's plug in that x1, y1 point. X of 1, we said was 4. And y of 1, we said was 3. So we've taken that original formula, we've plugged in what we know in the correct spots, and now we're just going to simplify, okay? So in this parentheses here, -3 take away a +4. So when you're taking away a positive from a negative, it's the same thing as adding on more negatives. So if you've got -3 and -4, that's going to be -7. And same thing here. So instead of taking away a positive, it's the same as adding a negative. So -7 and -3 is going to be a -10. So here we have -7 squared. What squared means is I'm going to take this number and multiply it by itself. And if you want to double check yourself, let's get out our yellow calculators, okay? Always make sure to put parentheses, especially if you're squaring a negative number. So -7, the squared button is going to be right here by the 4. So -7, press that squared button, press enter. That's going to give me 49, which they said, okay? Same thing here. This is basically saying, what's -10 times -10? Again, if you can't do that, plug it in, double check yourself. That's gonna be 100. And so we keep simplifying. 49 plus 100 is 149. If they want an exact answer, we stop there, the square root of 149. If they say, hey, I want my answer in decimal form, well, if you want a square root, notice it's yellow, so you'll have to press Control, the yellow button, and then the button that square root is above, okay? And type in 149. And again, if you ever want decimal answers, you have to click Control, Enter. So 12 point, let's say we'll round to the 10th, 12.2. All right, I'm going to do this check with you guys because I want to show you another strategy that you could use when you're trying to find distance on the coordinate plane. So distance formula, first of all, let's go ahead and try that. Anytime that you're using a formula, I would suggest writing out the original equation. And so again, if I forget, okay, let's look at our TCAP reference sheet. The formula is right there. Let's write this word for word as we see it. All right, now, a lot of you guys might be thinking, Miss Gibson, if I'm gonna write this every single time, that's a lot of work. And to that I say, just don't be lazy, okay? Because if you put in this work to begin with, it will save you a lot of heartache because writing this first keeps you from making mistakes in the future. All right, so we've written out the original equation. Now let's figure out which one's gonna be x1, y1, and what point's gonna be x2, y2. I'll make A x1, y1, and I'll make B x2, y2. And so now I'll plug in what I know in the appropriate spots. So x of 2 we said was 5. X of 1 we said was -6. And be careful here, guys. What a lot of people will do, they will write 5 minus 6. But the equation is one point subtracted from the other. So this point was 5, and this point was -6. So it's 5 minus -6. So just be careful of that. Now let's look at our y's. So y2 we said was 9. Y1 we said was -4. Now let's continue to simplify. 5, take away -6, minus minus turns plus plus. So that's going to be 11. 9, take away -4, minus minus turns plus plus. That's going to be 13. 11 squared, so that's 11 times 11, which is 121. 13 squared is 13 times 13, which is 169. Going to be the square root of 290. And again, if you want a decimal answer, it just depends on what they want. Here they did not really specify, so I'll go ahead and find the decimal as well. Take our yellow calculators, control that button, 290, control enter. So let's round to the nearest, we'll say nearest hundredth, so 17.03. Okay, so that is one way to do it. Another way, because we have a coordinate grid to work with, we can actually use the Pythagorean theorem. We started the semester with the Pythagorean theorem. If you've already forgotten, that is a squared plus b squared equals c squared. And this theorem is actually not on that TCAP reference sheet. This is definitely something you'll have to remember. But Pythagorean theorem can only be used for right triangles. So when I have 2 points here, what I'm going to do is I'm going to form a right triangle, and I'm going to connect A and B to represent that triangle's hypotenuse. Maybe you could draw your right triangle just like that. So I'm trying to find the hypotenuse. Hypotenuse will always represent distance. So if you want to make a note of that, do so. So now it's our job to figure out what's the length of A, what's the length of B, filling those in and finding that hypotenuse. So let's say this bottom side here is side A. Well, the x-coordinate of that point is -6. The x-coordinate of that point is a 5. So if we think back to these number line examples, right, when we wanted to find the distance from one point to another, we just subtracted those values and took its absolute value. So same thing here. So if this coordinate is at -6, this coordinate is at a +5, -6 minus 5 will give me that measurement. Let's do the same thing with side B. But now, if you notice, side B is going up and down. So those would represent the y coordinates. So we have a 9 and a -4 for the y coordinates. So it's going to be the absolute value of 9 minus -4. So now we have our lengths, and we can plug them in to do the Pythagorean theorem and solve for that hypotenuse. So that is going to be 11 squared plus 13 squared equals c squared. 121 and 169 is 290. And again, remember, I want my final answer to just be c, and to undo a square, you have to square root. So c, I'll do it in green here, c equals the square root of 290. Well, if you notice, that's the exact same answer that we got previously. And so we know the square root of 290 is about 17.03 units. Last example, example 4. These are real world problems, and they talk about how directions can represent coordinates on the coordinate plane. So you're gonna see a lot of this. They might talk about someone moving like so many units west, so many units north, and those will always represent coordinates, okay? So let's look at this word problem. Go ahead and read that and try to highlight any information that you feel is important to you. So I went ahead and highlighted the key bits of information you need. Again, in word problems, anytime you see numbers, you need to grab at those. That's what you're going to use. So here it tells me that Chelsea has a horizontal distance of 212.0 feet. Horizontal distance will always represent x coordinates because if you look here, horizontally you're going this way, so does the x-axis. So x coordinates will always be horizontal. And so the reverse of that also means your y coordinates will be vertical. Another keyword that I saw here, they talked about height. So height is just vertical distance. So height would always represent your y coordinates. So something else I wanted to mention, let's talk about like north, south, east, west direction. With coordinates, we know they can be both positive and negative. So how do we know which one is which? Well, if we look at, let's get our graph out again, okay? Let's draw an x and y axis. So we've got four directions that we kind of have to figure out, okay? North and south. So north is going up, south is going down. So which one do you think makes the most sense to be your positive value? Well, if you're going north, you're going up, okay? So north will always be positive. And south, you're going down. So south will be negative y values. Now let's talk about east and west. So if we're going east, we are going in this direction, right? Think back to grade school. We always said never eat soggy waffles. That's how you remember it. Or never eat shredded wheat. So to the right is east. And if you think about a coordinate grid again, those are going to be positive x values, positive y values. So east is a positive direction. And then west is going to be your negative direction because again, if you go in this way on the coordinate plane, these x values are going to be negative. So for your x coordinates,
east versus west, east are always positive, west are always negative.
And then your y coordinates,
north versus south, north will always be positive, south will always be negative.
All right, let's go ahead and finish up example 4. So they've laid out the distance formula for us, and they've told us which point is which. And this point is your x2, y2. And then from there, it's just filling in what you know. All right, so when you get to this point, you are now squaring. So when I simplified this term here, you got 223.3, and then you would square that number to get this big number here. Now you have to do the same thing for the other number. So we're gonna do 159.7 squared. And so that is going to be 25,504.1. But when you add those together, you get 75,366.98. And just make sure that you square root that to get your final answer, about 274.53 feet apart. All right, last thing, go ahead, try the check, and we will see how you do. So first off, I would always annotate key information because a lot of times word problems, they'll give us information that is totally not needed. So right off the bat, I'm gonna highlight my numbers. 20 miles west, 50 miles north, 15 miles south, 10 miles east. And the final question is asking how far away are the two boys from the resort? So if I look at these coordinates, 20 miles west, 50 miles north, I'm gonna have to turn that into an XY coordinate. So if we go back to our notes here, okay, our X coordinates represented either east or west. Well, he went 20 miles west, and we said west units would always be negative units. So that first X is going to be a negative 20. And then 50 miles north, okay, north or south represents the y coordinates, and north is a positive direction. So that is a positive 50. So this is the representation of those directions in a coordinate. Let's look at the next one. So we have 15 miles south and 10 miles east. Again, east and west coordinates are going to be your x values, and because he is going east, if we look back to our notes, east is a positive direction. So that's a positive 10. And then he goes 15 miles south. South is a negative direction, and that's on the y axis right here. So that's a negative 15. Now we have two coordinates here, and we can use the distance formula to solve their distance. So I'll call this one x1, y1. I'll call this one x2, y2. And now I'm going to simplify. 10 minus negative 20 is the same as 10 plus 20, so 30 squared. Negative 15 minus 50 is the same as negative 15 plus a negative 50, so that's a negative 65 squared. 30 squared is just 30 times 30, which is 900. Negative 65 squared is 4,225. And now I'm going to take the square root of that number. And so let's just keep rounding to the nearest hundredth. So that's going to be 71.59. All right, thank you guys for following along. Make sure you have these notes ready for when you come to class, and I will see you guys later.